Welcome to The Explainer. Today, we're going to take the critical, sometimes confusing science of global warming and completely demystify it. We're breaking this down into clear, easy to understand concepts using just the raw facts and the data. So, if you've ever wanted to understand the exact mechanics of what is actually happening to our planet right now, well, you are definitely in the right place. Let's get into it. Here's our game plan for today. First, we'll define the terms. Second, we'll look at the invisible blanket. Third, we explore how the heat is on. And finally, number 4, the human cost. All right, section 1, defining the terms. Let's get our vocabulary straight. So, global warming or climate change. You hear both of these phrases literally all the time, right? And they're often just totally swapped for one another in conversation. But are they actually the exact same thing? Well, fun fact, before the 1980s, scientists actually used the rather clunky phrase inadvertent climate modification. Catchy, right? Today, we use these two phrases, but they actually have very distinct scientific meanings. The U.S. Geological Survey draws a really clear line here. Global warming refers specifically to just the temperature rise, which is primarily caused by us pumping greenhouse gases into the air. Climate change, on the other hand, is sort of the big umbrella term. It includes global warming, sure, but it also covers all those broader, long-term shifts in weather patterns. We're talking changes in precipitation, wind, ocean currents, the whole shebang. And here is a crucial number to keep in mind. Since the dawn of the Industrial Revolution, our Earth's average surface air temperature has already gone up by about 1.5 degrees Celsius. That's roughly 2.7 degrees Fahrenheit. Now, I know what you might be thinking. 1.5 degrees? That sounds like practically nothing when you're just stepping outside to check the weather. But on a planetary scale, that is a massive, system-altering shift. Moving right along to section 2, the invisible blanket. Let's talk about the greenhouse effect. I want you to think of our atmosphere as exactly that, a giant invisible blanket completely wrapping the Earth. The greenhouse effect is just the natural process where heat-trapping gases in that blanket prevent the planet from losing its warmth to the freezing void of space. And honestly, we should be incredibly grateful for it, because without this blanket, life as we know it simply wouldn't exist. Here's the exact step-by-step of what's happening right above our heads. First, the sun's energy, which is shortwave radiation, enters the atmosphere super easily. It just zips right in. Second, the Earth absorbs about 80% of this energy and then radiates it back out as long-wave radiation. We just call that heat. Third, and this is the kicker, instead of all that heat escaping back into space, greenhouse gases absorb it and bounce it right back down to us. It's kind of like the heat checks in, but it really struggles to check out. So, what's this invisible blanket actually made of? Well, water vapor and clouds naturally do about 75% of the heavy lifting. But carbon dioxide, or CO2, which comes in at roughly 20%, is the primary gas driving our modern-day global warming problem. Why'd point the finger at CO2? Because while water vapor mostly just reacts to temperature changes, CO2 is an external force. We are actively adding massive amounts of it to the system. To really put the sheer power of this blanket into perspective, without these naturally occurring greenhouse gases, our planet would be 33 degrees Celsius colder. We'd be sitting at a totally freezing negative 18 degrees Celsius, literally a giant ice ball floating in space. So the greenhouse effect itself, absolutely crucial, a very good thing. The problem is just that we're supercharging it. And that brings us to the core issue today. Human activities, mostly burning coal, oil, and natural gas, are operating at a completely unnatural breakneck speed. Look, fossil fuels took millions of years to form from ancient plants and ocean plankton, but we are burning them hundreds, even thousands of times faster than they took to form. We are rapidly dumping all that ancient, stored carbon straight back into the sky. Because of this, atmospheric CO2 is now 50% higher than pre-industrial levels. We haven't seen levels this high for literally millions of years. Now, it is a really complex chemical system up there. When we burn fossil fuels, it releases those greenhouse gases that warm us up for decades, or even centuries. But it also emits airborne particles, things like soot and sulfur dioxide. And here's where it gets kind of counterintuitive. These particles actually reflect sunlight, creating a slight, short-term cooling effect, even though they cause terrible air pollution down here. But make no mistake, the net effect of burning fossil fuels is overwhelmingly warming, simply because the greenhouse gases stick around much, much longer than the cooling particles do. Okay, section 3, the heat is on. Let's look at the actual impacts on our planet. Trapping all this extra heat creates a massive domino effect all across the globe. We're seeing way more intense storms because, simply put, warmer air can hold more moisture. Up north, the Arctic is warming incredibly fast, leading to melting permafrost and shrinking glaciers. We're experiencing longer, much more intense wildfire seasons globally. And as all that excess carbon dioxide dissolves into the ocean, it causes ocean acidification, which is absolutely devastating to coral reefs and entire marine ecosystems. Now, here is a wild fact that a lot of people completely miss. While we definitely feel the brutal heat waves on land, our oceans are actually acting like a massive planetary sponge. Over 90% of the retained energy from this enhanced greenhouse effect goes directly into warming the oceans. This is causing marine heat waves, disrupting ocean currents, and it's a huge driver of long-term sea level rise. Because we just keep pumping out record levels of greenhouse gases. A recent paper presented at the UN Bonn Climate Conference noticed something pretty alarming. The current rate of human-induced warming has hit an unprecedented all-time high of 0.27 degrees Celsius per decade. The planet's vital signs are changing rapidly, right before our very eyes. Which leads us to our final section, Section 4, the human cost. What does this mean for society? All those environmental changes we just mapped out, they translate directly into severe and sometimes irreversible threats to human society. We are talking about tidal flooding creeping into coastal cities like Venice. We're looking at major agricultural shifts bringing widespread food and fresh water scarcity. Higher temperatures naturally mean more heat stress and heat-related illnesses. And ultimately, this entire cascade can lead to forced environmental migration, where people simply can no longer survive where they currently live. It's also really vital to understand that this burden is not shared equally. The most devastating impacts fall heavily on the communities that have the fewest resources to adapt. Poor communities often lack the infrastructure to bounce back from extreme weather. Indigenous peoples face huge risks because of their deep reliance on local ecosystems for basic needs. And staggeringly, the data shows that children under 14 are 44% more likely to die from environmental factors. Climate change is one of the biggest threats to global health in the 21st century. When organizations as prominent as the World Health Organization put out statements as stark as this, it underscores exactly why understanding the science isn't just some abstract academic exercise. It is incredibly urgent for our collective health and survival. The data is all mapped out, and the effects are happening to us right now. So I'm going to leave you with a provocative thought to chew on. We've seen exactly how this invisible blanket works, we know what causes it to thicken, and we see who it affects the most. The mechanics of global warming are fully demystified. But as the temperatures continue to climb at these record rates, the real question we have to ask ourselves is, what limits are we willing to push before adaptation is no longer possible? Thank you so much for joining me for this explainer. Keep asking questions and keep looking at the data.